So we're going to look at solving one-step linear inequalities, which will be very similar to linear equations with one little special thing that we need to think about. But before we start solving, let's talk about some notation that comes up with inequalities. So first thing we need to do is just interpret it correctly when we see an inequality. And I honestly still think about the alligator mouth, wanting to eat the bigger thing. I remember it's something I learned in second grade, I think. But it works, because the most common thing is misinterpreting which is the bigger value. So the alligator mouth is the idea that the inequality is a mouth, and it's going to be going towards the bigger thing because it's a hungry alligator. So in this case, I would read this as x is more than 2. In fact, I'll write that down for us. So the interpretation, x is more than 2. In this case, it's the same direction, but we have this line here showing that it can equal that value. So x is greater than 2, but it could also be equal to. So x is more than or equal to 2. In this case, with the alligator mouth facing the 2, that means 2 is larger here. So x is smaller than 2. So x is less than 2. And then here with that line, it's showing that it can equal. So x is less than or equal to 2. So that's how we would interpret these in words. Then we could have this different notation for expressing the inequality. So there's set builder notation, interval notation, or a graph. So set builder notation really mimics what we're seeing right here. What this would look like is we use brackets to represent a set. And what I would do is define the variable we're talking about. So I go x, and then we use this tall line to represent is defined by. So x is defined by x more than 2. So really it's just some extra notation on the outside, but then it comes down to the inequality inside. So x is defined by x more than or equal to 2, x less than 2, and x less than or equal to 2. So that's our set builder notation. For interval notation, what we're going to use is square brackets or parentheses. And we're going to list 2 numbers. We're going to list the smallest possible number and the largest possible number. So we'll have parentheses, or we'll have square brackets, or we'll have a mixture of the 2. So for x is more than 2, if I have my parentheses and think about the smallest value on the left-hand side for x and largest value. So 2 is going to be the smallest possible thing for x. So x is larger than 2, and then it doesn't have any bounds in terms of how big it can go. It can go off to infinity. So we're using 2 and infinity for our bounds for what x can be. Since I don't have equality here, I'm going to use the parentheses. So using parentheses there says it can't equal 2, but it's going to get really close, and that's the smallest value it can hold. And then going off to infinity, we can never equal infinity because we can't define it. As soon as you try to make infinity a number, you can always name a larger number. So with that, we always use parentheses with infinity. With x more than or equal to 2, it's going to be the same idea of 2 and infinity, and we'd use our parentheses with infinity every single time. But now because we can equal 2, I'm going to use a square bracket to show that 2 is the smallest number and it can equal 2. For being smaller than a value, now that number is going to be the upper bound for it. So 2 will be the largest possible value for x. And then the smallest it could be is negative infinity. So with negative infinity, same idea, we'd always use parentheses. Since we don't have equality with 2, we'd use parentheses. If we have equality there, then still parentheses for negative infinity, but we'd use a square bracket for the 2 since it can equal 2 now. So that's our interval notation. The graph, what we would do is we want to show this on a graph. So 2 off to positive infinity. So what we need is a number line. You can do this all sorts of ways. I usually put the number in the middle, and then I go 2 numbers above, 2 numbers below to show the direction that we're going in. So we should have increasing numbers, so 0, 1, 2, 3, 4. Let's go ahead and just draw this for each of these since we're using 2 every single time. As this number changes, you would use different numbers there, but this could give kind of a structure to use for these. 0, 1, 2, 3, 4. And last one, 0, 1, 2, 3, 4. Okay, so now graphing our solutions. So we want to show a graph at being 2 and above, but we can't equal 2. So what we do is we use an open circle. So we use an open circle, and then going off to positive infinity would go off to this right-hand side forever and ever and ever. What you might also see sometimes in terms of notation is using what we're seeing in the interval notation. You might see parentheses and then going off to the right like that, and those are showing the same thing. When it can equal 2, we would use a solid circle. So we'd close the circle and going off to the right-hand side there. Or what you would see like up above is square bracket and off to the right, and that would represent the same thing. For going below to negative infinity, so here we don't equal 2, and then we're going off to negative infinity, so we go off to the left-hand side. If it can equal 2, then same idea, but we'd use a solid circle and going off to the left. So those are different ways that we can represent our inequalities. Typically what we're going to come across is we'll be seeing this interval notation. We'll also be seeing these graphs for representing our answers for the inequalities. So now that we're getting to solving inequalities, a lot of the steps are going to be exactly the same as when we were solving equations. It's just now we'll have an inequality instead of an equal sign. But the one little trick that we need to be careful of is if we multiply by a negative real number or divide by a negative real number, then we need to reverse the direction of our inequality. So the inequality symbol will flip if we multiply and divide by a negative number. So that's a case that we need to be careful of when we're going through the solving process. So let's look at these one-step cases. So similar to our equations before, so here I have a plus 2. So to get rid of that 2 adding on to x, I need to subtract 2 from both sides. So that'll leave me with x. This is just a subtraction of 2, so the symbol isn't going to change, and 4 minus 2 is 2. And I'm going to express my solution in interval notation and then graph it. So this is saying x is less than or equal to 2, so I'm going to have negative infinity and 2, and since we can equal 2, I'll use a square bracket for a graph. Just a real quick graph here. I'll have a closed circle at 2 and then be going off to the left-hand side. So the idea is with a graph, then we're seeing all possible values that we can plug in that would make this work. So like if I plug in 1 right here, 1 plus 2 is 3, and that is less than or equal to 4. So it makes a true statement. All right. This next one, focusing on my variable x that I want to get all alone, I have this subtraction of 8. So to undo the subtraction, I'm going to add 8 to both sides. So negative 2 plus 8 will be a positive 6, and that is more than x. Or you could read it as x is less than 6. So this will be off to negative infinity, and 6 is the largest value. And then we'll have parentheses, And then for a graph, so here we finally have a graph using a different number. So I want to focus on 6. They'll go 2 above, 2 below, so that we get an idea of the order of our numbers. It should always go smaller numbers to the left, larger to the right. We'll have an open circle at 6, and then we'll go off to the left-hand side. And then again, you can kind of check your answers by like 4 should be a possible solution here. So if I plug in 4, so 4 minus 8 is a -4, and -2 is larger than -4. That's a correct statement. So you can plug in values. It's just a little different from equations because now there are infinite possibilities for all of the numbers that show up to the left of 6. All right. Here we have a number multiplying, and this is where I need to be careful. When I start dividing and multiplying values, I need to pay attention to, am I multiplying and dividing by a positive or a negative number? So here I'd want to divide by 4. So I'm dividing by a positive number, and that doesn't have a special rule for it. So with that, our inequality just stays the same. -12 divided by 4 would be a -3. So x is less than -3, so we'd be off to negative infinity again. And then the largest value would be the -3, and we'd use parentheses. So here we'd have -3, and I'm going to go 2 above, 2 below. So smaller numbers to the left-hand side, larger numbers to the right. And I'll have an open circle going off to the left-hand side. Last piece here, so I'm multiplying a negative number there. So I'm going to divide both sides by a -3. And this is where I want a little red flag going up in my brain that this is the special case that we need to be careful of. So in terms of calculation, that goes exactly the same. That would be x. 6 divided by -3 is -2. So that's all the same. But then what I need to be careful of is my symbol. So because I divided by a negative number, I need to flip the symbol. So where it was more than or equal to, now it's going to be less than or equal to. So it switched direction there because we divided by a negative number. So x is less than or equal to -2, so we'll have negative infinity up to -2 with a square bracket, but parentheses at negative infinity. So for a graph, I'm at -2, -1, 0, -3, -4, closed circle at -2, and then going off to the left-hand side. So that's how we solve our inequalities and the different ways that we can represent our solutions.